In this video lecture, I provide answers to homework assignment number 6. For this assignment, you were asked to distill and diagram more complex arguments than you'd seen in the past. Beginning on page 96, you were asked to distill this argument, put it into premise-conclusion form, and then diagram it. Reading along at the beginning, students are more likely to cheat in an online course than in classroom courses. I just want to point out too, this is a side note, that this problem was given to you on purpose. I want you all to know that I've put you on notice. No, I'm just kidding. Anyways, actually this was just the problem that was in the book. I had initially no thought process behind it. But in any event, when students take an exam in an online course, there is no one to monitor them. With the internet at their fingertips, students can look up answers online. Also, students might ask more advanced students to answer a particular question or take their exams for them. And this sounds like it's just giving you suggestions here. Anyway, taking an introductory biology exam would be no trouble for someone 3 years into a biochemistry major. There's simply more ways. Now it sounds like it's encouraging you. There's simply more ways to cheat in an online class without being caught than there are in classroom classes. And although they might not admit it, many students will cheat or help others cheat if they can do so without being caught. Alright, well, what's the argument here? I think it's fairly clear that the conclusion occurs in the very first sentence. Students are more likely to cheat in online classes than in traditional classroom classes. Now, how does it establish it? Well, it gives you several suggestions. I hate to use that word, but several reasons along the way. It says that you can look up answers more easily, you can ask it more advanced students, you can get more advanced students to take an exam for you. And just in the interest of time, I'm going to go ahead and put this argument into premise-conclusion form. And I think this is a fair reconstruction of the argument. Premise 1, when students take an online exam, take an exam in an online course, there's no one to monitor them. Students can look up answers to online. Students might ask for help from an advanced student on a particular question, or students might just get a more advanced student to take their exam for them. There are more ways to cheat in online courses without being caught. Many students will cheat or help others cheat if they can do so without being caught. Therefore, students are more likely to cheat in online classes. And I think this is fairly easy to get all the distinct propositions to even put them somewhat in a logical order. But what is a little more challenging is doing the actual diagram. And here's how I diagrammed this argument, what I thought was going on. The way I understood it is that premise 1 was actually given independent justification for 2, 3, and 4. The fact that there's no one to monitor you, well, that means you could look up answers online a little easier. The fact that no one is to monitor you means you could ask someone for help on a particular question. You shouldn't. The fact that no one is there to monitor you means you could just get someone else to take your exam. Now, none of you should be doing that. This is not an instruction manual on how to cheat here, but none of you should be doing that. But I think 1 does offer independent justification for 2, 3, and 4. And then 2, 3, and 4, I believe, is supposed to combine to lead to the conclusion that there are simply more ways to cheat in an online class without being caught. And then 5 and 6, those two combine to lead to the conclusion that students are more likely to cheat in online classes. So this is one way of reconstructing this argument. There might be other ways. You might have identified some implicit assumptions here, but I think this is a pretty fair way to present this argument. So that's problem number 2. Then you were asked to do additional exercises on page 100 and 102, and some of these were quite difficult, but we're going to go through them and see what we can come up with. So neither parole nor probation are justifiable. They are demonstrable failures in reducing inmate recidivism. Recidivism, for those who don't know, is just repeat offense. They undermine the deterrent impact of the law on criminals while demoralizing crime victims with their outrageous leniency. Most important, they jeopardize public safety. Now, here what I'm going to do in order to distill this argument is just go through and number the distinct propositions and also to strike out the information that's not needed. And you notice there are a couple of terms we don't need, and actually there are even more that we don't need here. But we just go through and we number all the distinct propositions that occur. And it seems clear that the conclusion here is the very first sentence, neither parole nor probation are justifiable. And then it gives you a number of different reasons. It tells you that parole and probation are failures at reducing inmate recidivism. That it is parole and probation fail to reduce repeat offense. They undermine the deterrent impact on law. They demoralize the victims, right? It's like if you're a victim of a crime and then the person who, let's say, assaulted you, they get out on parole, that can be demoralizing to you, and they jeopardize public safety. So I'm going to just list this argument in premise conclusion form, and this one's fairly straightforward. We just list 2, 3, and 4 with 2, 3, 4, and 5 from the top in order, and then we put the conclusion last. I did fill in some words here. I said parole and probation fail to reduce inmate recidivism, just so we could see the argument a little more clearly. If I was just writing they failed to reduce down here, then it wouldn't be clear. Well, what is they referring to? So I filled in the word they with parole and probation down at the bottom, and I made sure I had complete sentences down here. So this is the argument, and then we want to diagram the argument. And what is going on here, we have to ask, or 1 through 4, are they dependent or independent premises? And I think it's fairly clear that 1 through 4 are independent premises, all leading to 5. You could think about it in the following ways, like, well, suppose we didn't know if 4 was true. Would 1, 2, and 3 offer a reason for thinking that neither parole nor probation are justifiable? Well, yeah, 4, we don't need 4. What about 3? Don't need it. I mean, each one of these by themselves offer some reason for thinking that neither parole nor probation are justifiable. So here is how we would put this argument in premise conclusion form and diagram it. All right, now we come to problem 11, and this one I have to say was just a little obnoxious because of all the French in here, but excuse my French pronunciation at the outset because I'm not going to do well with it. But to the outsider, the chief reason for believing that Morelli was the author of Le Code de la Nature seems to be that Le Code contains somewhat fulsome praise of a bad allegorical political poem, La Basiliade, published 2 years earlier, and as it seems to be agreed that no one but the author of La Basiliade could possibly praise La Basiliade, it follows that the author of Le Code was the author of La Basiliade, who was Morelli. So this one's a little tricky, but it seems that the conclusion for this, what the person is trying to argue, comes in the very first sentence, that Morelli was the author of Le Code de la Nature. Now, why do we believe that, or what is the argument? How does he establish that? Well, it seems to be because we know that, let's go back through it. Seems to be that Le Code contains somewhat fulsome praise of La Basiliade. So this work, basically the idea is that there's this work, Le Code de la Nature, and we don't know who the author is. But we do know that it praises this other work, La Basiliade. And we know 2 things about La Basiliade. Number 1, it's terrible, and nobody but the author could possibly think it was good. And secondly, we know that Morelli wrote La Basiliade. So we don't know who wrote Le Code. We know Le Code praises this other work, La Basiliade, and we know Morelli wrote La Basiliade. So basically, from that, we conclude that Morelli was the author of Le Code de la Nature. Now, when we go through this, you'll notice that in this passage, there was a lot of unnecessary information, some little terms that we can omit from here and aren't really needed to get the gist of the argument. But here are the distinct propositions that occur, and here's how we would rewrite them in premise conclusion form. Notice that what I have listed in red as number 1 up here, that's actually the conclusion, and we're going to list that last down here. But here's how we can put this argument in premise conclusion form. Le Code contains praise of La Basiliade. No one but the author of La Basiliade could praise it. Therefore, the author of Le Code was the author of La Basiliade. So we kind of establish an identity there, right? And then number 4, well, we know Morelli was the author of La Basiliade, so therefore he must have been the author of Le Code. And this might be a little tricky, but once we diagram it, I think the argument will make a little more sense. You'll see we have these 2 sub-arguments going on. we look at number one. Le Code contains praise of La Basiliade. No one but the author of La Basiliade could praise it. Therefore, the author of these two works had to be the same. And since we know the author of the two works has to be the same, and we know Morelli was the author of one of them, he had to be the author of the other. So that's how we would distill this argument. This one, I don't think the argument is so complicated. I think all the terms in it make it a little difficult. I was like, why couldn't it have just said, instead of Morelli, been like Bill, and instead of Le Code, just said, I don't know, Moby Dick or something. I don't know, just something would have been easier if it said, I don't know, Huck Finn and Tom Sawyer or something. I was like, I could have followed that, but these, anyway, sorry. Oh, shoot. Well, number 15, I forgot to do my animations correctly here, but I'm just going to roll with it. This one wasn't an argument. So you might have been scratching your head and trying to figure out what was going on here, and maybe you ultimately gave up. But this, I told you there was one that wasn't going to be an argument. This was that one. So not an argument. And this is important because, like I said previously, you're going to have one on your upcoming test, or two, or three, or four, I don't know how many, that aren't going to be arguments. So always make sure to read through it and see if you in fact do see an argument, because you very well may not. Number 15 was not an argument. Number 18. This one's a tough one, but let's go through it. So let me now re-emphasize the extreme looseness of the structure of all objects. There is no perceptible object that does not consist of a mixture of matter and vacuity. In the first place, we find that in caves, the rocky roofs exude moisture and drip with trickling drops. Now in our own bodies, sweat oozes from every surface. Hair grows on the chin of every limb and member. This is just gross. Food is suffused through every vein, building and sustaining the most outlying parts, even to the nails. The stone partition of houses are pervious to voices and to scent and cold and heat of fire, which penetrates also through hard iron. So you might have read this and been like, what the hell is going on here? And you might have thought this one was the one that didn't have an argument. But it did. Now the argument here is one that probably none of you care about or think about, but in antiquity, there was a debate about whether or not things were composed of empty space or not. Now we know that some things are, because we know about how atoms work, and in fact there's a lot of empty space in atoms. But there was a time where people were like, well, I don't know if they're physical objects are composed just of matter and matter contains no empty space, or if there's also empty space in between it. And you go back even a couple hundred years before we had these very powerful microscopes, there was no way really to know. So people would give arguments for and against this idea that matter contained empty space, and this is one that comes from antiquity. In any event, this is an argument, and now it's a little bit difficult to. This actually comes from this ancient philosopher, I should have mentioned it, named Lucretius. He was an ancient Stoic. So, in any event, I wasn't Epicurean. I shouldn't have said anything. Now I'm like second guessing myself. But he's an ancient Greek philosopher. This is trying to give an argument that all perceptible objects consist of both matter and vacuity, which just means empty space. That there's some empty space and some matter in every object. So that was the first step of figuring out what the argument here is just figuring out the conclusion. I know this one's tricky just because it's so far removed and so unfamiliar to anything that we nowadays think or care about. But it is trying to give an argument that everything is composed of matter and empty space. And the way that it tries to do this is basically establish that there are a lot of different types of objects that are porous. Notice that our body is porous. Sweat oozes from every surface, hair grows from every chin, and food is suffused through every vein. Then it gives another example that stone partitions, so stone, right, is pervious, like voices, scent, cold, and heat can go through stone. Actually, I skipped over one. It says, if we go back to, it says, in the first place, we find that in the caves, the rocky roofs exude moisture. Then finally it says also that hard iron is also pervious to these various things. So we're going to try to list the argument here. And as I said, the very first statement is the conclusion, and we can omit what I have outlined or struck through here, and we don't need that. And then let's try to identify the argument that's going on here. And we have, I just said a couple of different examples that it's giving. I'm just numbering those of things that are porous: the rocky caves, our bodies, stone partitions, and even hard iron. And I'm going to summarize the argument in this way. And there are other ways you could do it, but rocky caves exude moisture, premise 1. Sweat, hair, and food passes through our bodies. That's going to be premise 2. Now you might have broken this one into 3 distinct premises. You might have said sweat passes through our body, hair passes through our body, food passes through our body. You could have done that. That would be fine. I just simplified it. Voice, scent, heat pass through. I just combined stone and iron. You don't have to do it that way. You could have said voice, scent, heat, pass through stone. And there is reason you could have said, and you could have come down and said voice, scent, heat, pass through iron. Or actually, and there's another way you could have read this. Sorry, I'll go back a line. You might have thought that when it says also penetrates through hard iron, you might have thought he was referring to just the heat and cold, not the scent and the voices. But you could read it as saying that the scent and voices and heat and cold pass through hard iron. It's a little unclear. And then from this he concludes, therefore there is no perceptible object that does not consist of mixture of matter and empty space or vacuity. Now this isn't quite done yet because there seems to be an assumption that's going on in this argument. And there are actually maybe a couple of different assumptions that are going on in this argument, but one of them is if an object allows something to pass through it, it must have vacuity or empty spaces, right? Because you might have been scratching your head and thinking, well, why is the fact that these things pass through it? What does that show? And it has to be assuming that if something, if one object can pass through another, that it can only do that because there's some kind of empty space there. There are other assumptions that are occurring in this as well. Whoops, sorry, I clicked my finger too much. Another assumption I think this argument is probably making is that rocky caves, sweat, hair, food pass through our body, voice, scent, heat pass through stone and iron. I mean, notice here it lists rocky caves, our bodies, stone and iron. It doesn't list every single perceptible object on the planet. But it has to be making some kind of assumption that these, 4 different perceptible objects that it lists are representative or indicative of all perceptible objects. Because, it doesn't mention, trees or grass or, other types of perceptible objects that exist. So it has to be making some assumption that they are representative of all of those. But let's just ignore that for a second and then go on and try to diagram this argument. And I think the diagram is going to consist somewhat like this. And we just say 1, 2, 3, 4A because it's our assumption, and that all leads down to 5. This argument, as I just said a moment ago, it is making many, many other assumptions. The biggest one, and maybe we could have diagrammed this too, I just didn't want the argument to get too complicated, is that these 4 bodies are somehow representative of all other bodies. So we're going to need a way to include that because the argument is just incomplete as it's stated. And there are a number of different ways we might go, but I'm just going to suggest one, and this is, I think, a fair representation of what the argument is assuming. But I think it's going to be assuming something like what I have listed as number 4 up here. Therefore, all physical bodies allow objects to pass through them. And I think what is going on is that 1, 2, and 3 are leading to 4. Now, I have to say, that's way premature to draw 4 from 1, 2, and 3. I mean, you looked at 4 different types of objects and then said, therefore all of them, allow objects to pass through them. But we're not going to worry about the plausibility of the argument. We're just trying to get a sense of how the argument is going. Now once we fill that in, now we're in a point to offer a full diagram of the argument. And I think it's going to look something like the following, that 1, 2, and 3, they all lead to 4. 4 and 5, and notice I have my A's listed over here to indicate that 4 is an assumption and 5 is an assumption, that those two combine together to lead to 6. Now you might wonder again, well, why didn't you put a C out beside 4 since 4 is an implied conclusion? Well, I didn't do that because the fact that it's a conclusion is following from this arrow, and it seems like it actually is a little tricky why you wouldn't do it, but basically, 4 is something that is being assumed within the argument. We'd only put a C if the conclusion is implied at the very end. But we're going to just use A to indicate that 4 is something that's being assumed to follow from 1, 2, and 3, and 4 and 5 combine to lead to 6. All right, now we come to problem number 20, and this one was by far and away the most difficult one. If you thought the last one was hard, when you got done with that, you probably were cursing the day I was born when you started to do number 20. Now, I know some of you may be a little bit miffed that I gave you a problem that was so difficult, but I want to say a couple of things about that. Number one, the purpose of this class is to stretch you and to challenge you and to force you to think about things that you ordinarily wouldn't. And the reason I want to give you some really difficult problems is so that when you have to deal with figuring out what somebody is saying in real life, it'll be a whole lot easier. It would really serve you no benefit if I just gave you easy problems all the time, because then you just wouldn't be learning. And I give you difficult problems kind of for the same reason that JFK said we tried to go to the moon. I don't know if you guys know his famous speech. He said, "We do these things not because they are easy, but because they are hard." And that's the reason that's part of the reason I'm giving you this as well. So there's a certain struggle and challenge in doing really difficult problems. And there's a certain kind of sense of accomplishment also that comes about from doing that. But going back to the earlier point I was making, this class is kind of like training you for a big race. And this problem, I don't know if you guys ever seen people train for races, but they'll run with like parachutes on their back, because by doing that, if you can run maybe at half speed with the parachute on your back, then when you you run as hard as you can, but you're not going particularly fast with the parachute on your back, do that a couple times, take it off, and you'll be faster. Same thing here. I don't know if you've ever seen like basketball players, like I've seen them wear like ankle weights during practice, because then they take them off, they'll just be quicker. It's the same thing here. We're stretching your brain, stretching your mind, so that you'll be more agile and stronger and faster when you get into the quote-unquote real race. So, if you struggle with this one, I understand. I honestly thought about this one for well over a day. I didn't just sit at my computer thinking about it, but I thought about it. I was like, I think this is how you do it. And then I was like, no, it's not going to work. And I came back to it. So if you struggle with it, don't feel like you're dumb. This was a tough one. Now this comes to us from Charles Darwin. I don't know if you remember reading it in the text, but this is from his Origin of Species. And I'm going to just read it, and then we'll see what we can do with it. So here's what it says. A struggle for existence inevitably follows from the high rate at which all organic beings tend to increase. Every being which during its natural lifetime produces several eggs or seeds must suffer destructions during some period of its life, or during some season or occasional year. Otherwise, on the principle of geometrical increase, its numbers would quickly become so inordinately great that no country could support the product. Hence, as more individuals are produced than can possibly survive, there must in every case be a struggle for existence, either one individual with another of the same species, or with the individuals of distinct species, or with the physical conditions of life. Now that's a mouthful. What is he saying? Well, whenever we try to distill an argument, the first thing we want to do, if we can, is figure out the conclusion. And I hope you guys noticed that there were some indicator words in here. In the very first line, a struggle for existence inevitably follows. That's an indicator word. If I say A follows from B, that means A is a conclusion that results from B. Inevitably follows from. I should have highlighted from here, but it inevitably follows from. And then notice down here, so a struggle for existence inevitably follows from. Notice down here, 3/4 of the way through, a little over halfway, hence, that is a conclusion indicator phrase. And so hopefully you were able to figure out that what this is trying to establish is that there is a struggle for existence in the natural order. There's a struggle for existence. That's the main conclusion that this argument is trying to establish. And truthfully, that's somewhat the easy part. The hard part is figuring out why is there a struggle for existence? But that's really what Charles Darwin was trying to establish here, is that there is a struggle for existence. Now, how does he establish this? What is his reasoning behind this? And then once we figure out kind of what I want to do is try to get a general sense of his reasoning for this conclusion. And then once we get a general sense of it, then we can start to pinpoint the premises. I should say at the outset that distilling this argument is going to be different than a lot of the other ones. A lot of the other ones, we just go through and number all the distinct premises. This one, it's not so easy to do. And this one, we're going to have to do a fair amount of interpretation and rewording, and it's not going to be as nice and linear as some of the other examples we've done. So we know that he wants to establish there's a struggle for existence, and we get a hint of his reasoning from both of the lines in which the conclusions occur, or in which the conclusion occurs. Now, I should say, before I tell you what this is, notice that what he says in the first line up here in red, and then the second line I have in red, he's just saying the same thing. So he actually repeats his conclusion a couple of times. So there's redundancy in his presentation of this argument. And when we summarize it and put it in premise-conclusion form, we don't have to, rewrite the conclusion twice. I mean, we'll end up deleting one of these. But as I was saying, we get a hint of his reasoning in both of these lines. And notice what he says in the first line. A struggle for existence inevitably follows from. So we know that what's in red in the first line, this is going to be the conclusion, and then he's telling us his justification. He's saying A follows from B. Well, what is B? The high rate at which all organic beings tend to increase. So a struggle for existence follows from the high rate at which all organic beings tend to increase. So something about, he's suggesting here something about the rate of population increase, leads to the conclusion that there must be a struggle for existence. He repeats that in a similar way down here. Notice that we move down to the second line I have in blue, but he starts off this way. He says, hence, as. Notice that indicator word there, as. This is kind of an interesting way of writing. He puts a conclusion indicator word right next to a premise indicator word. But he says, hence, as more individuals are produced than can possibly survive. So we know that what comes after as, what immediately comes after that is going to be the premise. So the premise here, or the rationale, is more individuals are produced than can survive, therefore there must be a struggle for existence. So we're getting this argument here. It's a little bit unclear what he's saying, but it's something along the lines of, so many individual organisms are produced that there must be a struggle for survival. So the premise here, if we were going to state it at this point, would be premise, the population of organisms increase at a great rate, and there's so many that are produced, and a lot of them are produced, something along those lines, therefore there must be a struggle for survival. Now that argument is not entirely clear, and there's a whole lot more going on in this passage. And we need to figure out exactly, well, how does all this other information fit in? Now, I want to skip down to the bottom, and I don't have a distinct slide for this, but look down here. Either one individual with another of the same species, or with the individuals of distinct species, or with the physical conditions of life. All of that is not really telling us any of the justification for his conclusion. What that is it's really where you start at the word either down here, the third line up. That's not telling us any justification. That's just clarifying the nature of the struggle that must exist for survival. So truthfully, as we're summarizing the argument, we're going to put it into premise conclusion form. We can just ignore everything from the word either in the third line down to the end. That's just clarificatory information to explain what the struggle is like. So that's not really telling us what the justification is. So we're just going to ignore that. And I should have had a slide in which I crossed that out, but I forgot to do that. But we're still returning to this question. Well, how exactly is he establishing this problem about the increase of population? What exactly is his justification there? And we get a hint of it a middle way through the passage. And he uses this phrase, you'll see it appear in green here, geometrical increase. He's saying something in the middle here about how the population increases at a geometrical rate. Now, this might be a phrase that's unfamiliar to some of you, so I want to just stop here for a second and define this and get clear on what we're talking about, because if we're not clear on this, the rest of the passage isn't going to make sense. What is he talking about? He says, otherwise, look at the phrase, or the term, otherwise, on the principle of geometrical increases, its numbers will quickly become so inordinately great that no country could support the product. What does it mean for a geometrical increase to occur? Well, this is, I guess, a term that's not always used. Sometimes people use exponential increase, geometrical increase. In this context, they mean the exact same thing. But it seems like what Darwin has in mind here is that the population of a given species increases or has the potential to increase at a geometrical rate. Well, why is that? Or why would he think that? Well, and what exactly does he mean? Now let's return to this. Well, geometrical increase or exponential increase is going to be something, you think of it like the following term. In the following sense, is this chart I have up here. So suppose that I were to have 2 children, right? If just I had 2 children, then there would be 3 people in the world, right? Actually, there'd be 6 because, I'm sorry, actually there would be 4 because, presumably I'm not having these children alone. So, if I had, 2 children, then, let's just say for simplicity it'd be 3. And then imagine each of those had 2 kids. Well, then you'd have 7 people, right? Actually, you'd have more than that because presumably they have someone they're having the kids with. But then imagine each one of those had 2 as well. Well, then you have 15 people. And then imagine each one of those had 2 kids. You can see where this is going very, very quickly. You're just going to have this population explosion. And that's on the assumption that, each of us is only having 2 kids. What if each of us were having 3 or 4? Very, very quickly, the population would explode just because of this. This is geometrical increase here. And this is what he's saying in the middle of the passage, is that there's some kind of geometrical increase, or the geometrical increase is a problem or a possibility. You might have heard of this, people talk about like the population bomb or the population explosion. I mean, this is the idea that's going on here, is that populations of organisms can increase at a geometrical rate. And you can see how that will occur. Well, if each of them is having 2, at least 2, and so on and so forth, the population is going to explode very, very quickly. All right, so we get that idea, but how does that fit in? And here we have actually another indicator word that's going to tell us some important information. The word otherwise appears just a few words prior to geometrical increase. And it's important that we read this sentence. This is an extremely long sentence. It begins with the word every. Every being, and it's the second line, which during its natural lifetime produces several eggs or seeds, must suffer destructions during some period of its life and during some season or occasional year. Otherwise, on the principle of geometrical increase, its numbers would quickly become so inordinately great that no country could support the product. Hence, now I mention that hence, because what we see here is we have an argument going on, and it is acting as a sub-argument for the main conclusion, hence. Well, what is this sub-argument that's going on? Well, it seems to be saying, or Darwin seems to be saying something along the following lines, that every being must suffer destruction. Otherwise, there would be this geometrical increase of the population. And if there was this geometrical increase of the population, then the earth basically couldn't support the entire population of that species. So again, the basic idea here is going to be something along the following lines: that if individuals didn't die out at some point during their natural lifetime, then what would occur is the population would explode at a geometrical increase. And if it exploded at a geometrical increase, then the Earth couldn't support it. And so that's the general sense of the argument that's going on here. I think what Darwin has observed is that there's this potential basically for just this explosion of a population. And if the population exploded, then you just wouldn't have enough natural resources to support the population that existed. But even though there's this potential for this population explosion, it doesn't occur. And why doesn't it occur? Well, because some people have to die out during their natural lifetime. So we can try to put this in the premise conclusion form, and here it gets a little tricky because I'm going to try to reword some of these things. I mean, these are very complicated sentences, and I think this is what makes reading it so hard. I mean, like I said, look up here. There's one sentence that goes from line 2 all the way down here. It goes, let's see, hold on. Oh, my cursor went away. So it goes 1, 2, 3, 4, 5, 6 lines. I mean, that's a hell of a sentence. I mean, truthfully, I just now noticed this, only 3 sentences in this entire paragraph. The first one is pretty straightforward, but then, second sentence is 6 lines, and then the final sentence starts at hence is 1, 2, 3, 4, 5, and then bleed over into a 6th line. I mean, if you ever wrote that way for your English class or for one of my philosophy classes, I'd tell you to clean up your prose, but I guess, Charles Darwin is a scientific genius. He can do whatever he wants, but not really good writing. But in any event, we want to summarize this argument, and I think here is a first pass at a summary of this argument. If every individual organism lived out its natural lifespan, the number of organisms would increase at a geometrical rate. If the numbers of organisms increased at a geometrical rate, the Earth could not sustain them. Hence, not every organism can live out its natural lifespan. Hence, there must be a struggle for survival. And like I said, this is a first pass at the argument we're trying to summarize here. And even getting here was a bit of a struggle for your existence. Charles Darwin's writing. But I digress. But even just to get to this point, we had to do a fair amount of work. Now, this argument, as I presented it right here, this summary, I should say, it's missing some information, and it doesn't tell us everything. I mean, after all, there's a big question about number 1 up here. It's like, why is there going to be this geometrical increase if every organism lived out its natural lifespan? Well, he actually answers that, and if we go back to his presentation of the argument, we'll notice in line 2 what I have listed up here. I've underlined and put in, what color is that? I don't know, reddish. I don't know what color that is. Anyway, I'm sure I'll get an email from one of you telling me. But here's something he says. Every being which during its natural lifetime produces several eggs or seeds. It seems like what he's saying here is that every being produces several eggs or seeds. Now, that can't be what leads to the population bomb, because just producing eggs or seeds is not really going to create any kind of population at all. It has to be something a little stronger, which is that not only does every being produce eggs or seeds, but they actually produce offspring, because it's offspring that are really leading to this population explosion. So we can reword what he said here to be a little more precise and maybe say something like this. Every organism produces several offspring during its natural lifespan. And if every individual organism lived out its natural lifespan, the number of organisms would increase at a geometric rate. If the number of organisms increased at a geometrical rate, the Earth could not sustain them. Hence, not every organism can live out its natural lifespan. Hence, there must be a struggle for survival. And the way we've worded this up here, summarized it, I'm getting a little bit ahead of myself, but 2 is supposed to follow from 1. 2 is supposed to follow from 1. And you can kind of see how that would go. It's like, well, look, every organism produces several offspring, And then just logically, it would follow that there would be this geometric increase of the total population. Going back to the slide, I had several, screens ago where, I had I produced, two, and my children produced two, and so on and so forth. You can see that if everybody is producing two kids, at least two kids, there's going to be in a short amount of time a geometrical increase. So this is, our second attempt at this argument. You might say version 2.0. And this is, I would say, 95% of the way there, maybe 90% of the way there, but we're still missing something that is going to be greatly needed. And what we need to do is fill in this jump in the logic, and the jump occurs between 3 and 4. And I want you to pay careful attention to this, because the way it was going along a second ago, the argument was being presented a second ago, 5, as the screen now shows up here, was supposed to follow from 3. But I've said this before, is that you can't draw an affirmative, definitive claim from a mere hypothetical. And 3 is a mere hypothetical. It's just saying if the number of organisms increase at a geometrical rate, the Earth cannot sustain them. And then, as we have worded it, hence, not every organism can live out its natural lifespan. There has to be something going on there that's going to enable us to move from the hypothetical in premise 3 to the affirmative conclusion in 5. There's some assumption that this argument is making, and it's not entirely clear what it is, but I think it's going to be something like this. The Earth does support some of the numbers of organisms. Something along those lines, or maybe the Earth does support the population of some species, or some portion of the population of species, something along those lines. You could fiddle around with it, maybe get a little more precise. But look at it now, and you read through the argument, and it's saying if the number of organisms increased at a geometric rate, the Earth could not sustain them, but the Earth does sustain them. Therefore, the number of organisms doesn't increase at a geometrical rate. And then we actually can move further back. We say the number of organisms doesn't increase at a geometrical rate. Hence, not every organism can live out its natural lifespan. So I think this is something, an assumption that the argument is going to need in order to work. And then once we flesh this out, we have the argument, I think, presented basically as Darwin did. And in fact, this is more or less the answer that the book provided. And this is kind of funny. Even though I had the book's answer, I had to spend some time thinking about it. The book, the answer that the book text, the answer key gave me, actually didn't have assumption number 4 filled in. That's something I think that it's going to need in order to work. But now that we have this, we can diagram this argument. And I think, as I said earlier, it seems that 1 is supposed to lead to 2. And then once we establish 2, I think the next step is going to be something like the following. I forgot to make a correction. You probably saw the screen just adjust. Initially, I had the word population instead of number, but I changed it to number just to remain consistent. But anyways, you probably saw the screen just jump over at number 3, but just ignore that. Pay no attention to the man behind the curtain. But going back to our diagram, then what's going to happen is 2, 3, and 4a are going to combine, and that's going to lead to 5, and 5 is going to lead to 6. So, that was something, huh? You guys probably didn't know it was going to be this much fun when you signed up. But this is basically how you would diagram and distill this argument. Now, here comes the real fun. Because some of you might have been thinking, now look, if you're content, if this is an answer and you're like fine with it, you can stop right there. But I'm going to give you a little bit of extra credit, I guess. Well, not really extra credit, just extra information. Because some of you might have been looking at this and just thinking, premise 1 just seems wrong. Because every organism doesn't produce multiple offspring during its lifetime. It doesn't produce several offspring. There seems something just deeply false about that. And I'm going to comment on that and say a way that I think is more charitable to Darwin's argument than the way I just summarized it. And maybe it's a better presentation, or maybe it is what he meant all along. I'm not entirely sure. The way that we've summarized it here is actually perfectly consistent with everything he said. But there might be a more charitable way to understand it. And like I said, number one seems wrong just because I bet every single one of us knows at least one person who during their, lived out their entire life, lived into their 80s or 90s or whatever, never had any kids. That happens. That happens all the time. And I mean, not for everybody, of course, but it does happen. And it happens, I imagine, for other animals as well, that they live out their life and they just never mate or have children. So, this idea that every organism produces several, or this proposition that every organism produces several offspring, just strikes me as false. So if Darwin's argument hangs on this, the argument just fails in the end because it rests on a false premise. And I think there's a more charitable way to understand what he's saying that skirts this problem. And here's how, I told you, it's like I spent a lot of time thinking about this argument, and here's, part of where I spent a lot of my time, because I was like, this is accurate, it's, capturing what he's saying, but it's wrong. And not to say that Charles Darwin couldn't be wrong. I mean, some of you probably think he was wrong about everything, and certainly he's just a man like the rest of us. But, if there's a way we can reconstruct this argument that doesn't require him saying something false, then that's more charitable and we should do it. And I think there is. And here is my suggestion as to how we should understand what he's saying, is to say something like this instead. If every individual organism that produced multiple offspring lived out its natural lifespan, the number of organisms would increase at a geometric rate. Now, notice here that I'm not saying that every organism actually does produce multiple offspring. I'm just saying that for all the organisms that do produce multiple offspring, or rather I'm suggesting that there are enough of them that do produce multiple offspring, that the population would still increase at a geometric rate. And that seems that number one would be true, because let's suppose, there's 10 people and 3 of them never produce children. Well, the fact that 7 of them, and let's say that 7 of them, the 7 remaining, maybe 2 of them produce only 1 kid, and then the remaining 5 produce multiple kids. Well, as long as enough of them are producing multiple kids, I think we're still going to have that worry about a population explosion. Because you don't have to have 100% of a population having multiple children in order for the population to increase at a geometric rate. You just have to have enough of them doing it. And I think that seems reasonable, that we would have enough of them doing it. So we can reorganize the first premise to say something like this, or restructure it to say something like this. And then we escape that problem where we are imputing a false premise to him. And if we do this, then we're going to have to draw up a new diagram as well. And I think the way of rediagramming this argument is going to be something like as follows. Sorry, my animations are off here. Something like as follows, and we just combine 1, 2, and 3a. They lead down to 4, and then 4 leads down to 5 as follows. So this is another way, and I shared this with you because I've said this before, but there's more than one way to distill these arguments and diagram these arguments. And as far as this goes, you'll find that people disagree with one another and say, no, that's not the proper way to understand the argument. I mean, there's fields of study that are dedicated to just textual reconstruction, trying to figure out what someone has said. And it gets very complicated. And so I'm trying to demonstrate some of the complexity of that to you. Oftentimes there's not, and I know I'm repeating myself here, there's not a simple, easy, well, this is the one way it has to be done kind of answer. There are going to be a range of reasonable answers, and I think I've just provided you 2 different interpretations of this one argument, both of which strike me as within the ballpark. So hopefully, I know some of you may not have been able to get this on your own, but seeing this and seeing the thinking process behind how we work this out, I hope that that will provide some understanding to you.